Hello everyone, my name is Samuel Esong and welcome back to my YouTube channel. So in the last class or in the last video, we clearly understood what Kubernetes is. We also saw why it exists and we also saw the problem it solves after Docker. So in this video, we are going one level deeper, all right? Still, we are not deploying anything yet, all right? So it is more like we are opening up the engine, all right? So we are going to look at Kubernetes architecture and distributions in today's video. All right, again, please, if you are yet to subscribe to my YouTube channel, please, I would love you to subscribe to my channel. Share this video with your friends, share this channel with your friends, and comment and also like this video. Let us get right to it. All right, so before we start, let me remind us that Kubernetes is not magic. All right, Kubernetes is not magic. Kubernetes is actually easy. All right, so let me remind us that Kubernetes is actually easy. So understand Kubernetes as a group of components working together. So if you understand who does what, if you understand who talks to who, then Kubernetes becomes very easy to reason about. So in today's video, I want to understand just one big picture. All right. So understand that a Kubernetes cluster is divided into two main parts. You have the control plane, then you also have the worker nodes. All right. So everything else fits inside these two ideas. So understand that a Kubernetes cluster is made up of machines. Now, these machines are split into two logical groups, which I have already stated here, the control plane and the worker nodes. Now, what is a node? What is a node? So, a node is simply a machine, all right? A node is synonymous to a machine. It can be a virtual machine, or it can even be a physical server. So this is all what you need to know about node. Now, what is the control plane? So you can understand that the control plane is the brain of the cluster. All right. It does not run your application containers. It manages the cluster. Let me repeat. The control plane does not run your application, but the control plane manages how your application runs. So the control plane is responsible for deciding what should run. It is responsible for where it should run. It is also responsible for watching that the cluster stayed in the desired state. So if Kubernetes were to be a company, all right, the control plane is simply the management. Now, what is the worker node? Worker nodes, what are they? So worker nodes are where your applications actually runs. So your containers run on the worker nodes. Your pods runs on the worker nodes. Your back-end application, front-end, background jobs, workers, all of them runs on the worker nodes. So you can have this very clean separation that the control plane is in charge of management and decisions, while the worker nodes is in charge of what? The actual workload execution. So because now this separation is extremely important because later when something breaks in your cluster, you must know if that problem is a control plane problem or if that problem is a worker node problem. All right. Now, some people may think that the control plane is a special server that only exists once. But in production, you usually run multiple control plane or control plane machines. Now, this is usually for high availability, but conceptually, it is still one logical control plane. So let us take a look at the major components in the control plane. So if we take a look at this diagram, you can see that the left hand side is the control plane and the right hand side is the worker nodes. Now, these are the components of the control plane. We have the API server, we have the kube scheduler, we have the controller manager, and we have the etcd. So these are the hearts of Kubernetes. Now, what is the API server? The API server is the front door of the cluster. So everything goes through the cluster. Sorry, everything goes through the API server. All right. So when you run commands, when you're trying to talk to the cluster, it goes through the API server. So you are not talking directly to the nodes. You are talking to the API server. Every request, all the requests go through the API server. So you can think of the API server as the central communication hub. Nothing bypasses the API server. But understand that the API server does not do heavy logic. All right. So what it does is it validates the request, it stores or retrieves data, and triggers the rest of the system. So if API server is the main entry point, then what is etcd? So etcd is the key value store used by Kubernetes. etc is the key value store used by Kubernetes. All right. So you can simply say that etcd is where the entire cluster state is stored. So you can also see it that etcd stores what pod exists, what deployments exist, what services exist, what namespaces exist, what node exists. Everything is stored in etcd. So if someone should ask you, where does Kubernetes stores its state? Then the answer should be etcd. So if etcd is unhealthy, then your cluster is unhealthy. And please understand that you never talk to etcd directly as a normal user. So as a user, you go from the API server. All right. So what is the kube scheduler? So the scheduler answers one very important question. On which worker node should this pod run? This is the major job of the kube scheduler. When you create a pod or a deployment, Kubernetes creates a pod object. At that moment, the pod has no node assigned. All right. So the scheduler will look at the available nodes. It will also look at the resource capacity. If there are rules, it will also take a look at the rules. If there are constraints, it will also take a look at the constraints and select the best node fit for that deployment. Then after that, the pod becomes bound to a node. So you can simply say that the scheduler does not start containers. All right. It only decides placement. Then what is the control manager? This is the most abstract one, especially for beginners. So the control manager runs controllers. All right. It is more like a loop that constantly checks what is the desired state of this deployment and what is the current state. And if there are any differences, the control manager will do what? Try to fix the differences. For example, if I should say that I want 3 replicas of this application, the controller is going to check how many replicas are currently running. If it sees only 2, it creates another one. All right. So this is how Kubernetes enforces your desired configuration. So controllers are responsible for keeping replicas correct, handling node failures. It is also responsible to reacting to object changes and most especially maintaining consistency. So in simple English, you can simply say that the controller manager is the system that keeps fixing things automatically. So this is why Kubernetes is called self-healing. So let us go through all this again. The API server is the main entry point of your cluster, all right? The etcd is your cluster database. The scheduler chooses where your pods, your deployment should run. Now your control manager keeps the entire system in the desired state. Now let us look at what actually runs on the worker nodes. So on the worker nodes, on the left hand side is where you have the worker node. So these are two worker nodes. The first one is node 1 and the second one is node 2. All right, so we are going to pick one of these guys and analyze. So in a typical worker node, you are going to see a small agent called kubelet. You are also going to see kube proxy, and you're also going to see container runtime. All right, so the kubelet is responsible for talking to the API server. All right, so what happens is that the kubelet receives instruction, and maybe the instructions can be to start a container on that particular node. All right, so the kubelet is responsible for taking instructions, and it takes this instruction from the API server. So the container runtime is what actually runs your container workloads. So your container runtime is actually what runs, it is a software that runs containers, all right, on the host machine, all right. So it handles image management, container creation, container execution, resource management, and the rest of the stuff. Now, the popular container runtime includes Docker, CRI-O, Portman, RKT, Containerd, etc., etc. So how about kubeproxy? So kubeproxy is more like a network proxy that runs on each of your worker nodes in a Kubernetes cluster. All right. So the primary function of a kubeproxy is to implement service, load balancing, network rules. So we are going to see all of this in depth when we start implementing cluster configurations. All right. So a kubeproxy is a critical component of a Kubernetes cluster, ensuring that the services running on a particular node are accessible and traffic is what? Routed correctly. So now you can, from this explanation, you can see that the control plane decides and the worker node executes. All right. So now that we have seen the Kubernetes architecture in details, now let us also see the Kubernetes distributions we have. When it comes to Kubernetes distributions, there are two main approaches. We have the self-managed distributions, or simply the self-managed clusters, and the managed clusters. Now, in self-managed clusters, you are responsible for everything. That means you manage the control plane machines, you manage the upgrades, you manage the certificates, you manage backup of etcd, you manage high availability, and of course, you manage the node lifecycle. So what I'm trying to explain is that in self-managed, all right, you simply install Kubernetes yourself. Usually you use tools like kubeadmin. All right. So this gives you maximum control of your clusters, but it also gives you maximum responsibility. So in essence, if the control plane goes down, you are responsible to fix it. Now, how about the managed clusters? Or yes, the managed clusters. So in a managed Kubernetes, the cloud providers provide or runs the control planes for you. All right. So that means the cloud providers provide or they manage your API servers, etcd, upgrades, high availability. They also purchase your Kubernetes clusters for you. So with a managed cluster, you simply focus on your worker nodes and your workloads. All right. And a very popular example is EKS, Elastic Kubernetes Service, a managed Kubernetes service from AWS. So you do not maintain the etcd, you do not log in into the control plane servers, you only connect the server and you start deploying your workloads on the servers. So if you are looking for reliability, security, and less operational burden, then you should go for managed clusters. All right. So we have already struggled with provisioning servers in our previous videos. We have seen how networks are provisioned. We have also seen some infrastructure issues. So now imagine also managing the control plane, cluster upgrades, etcd backs up. So this is why managed Kubernetes became very popular. But it is still very important to note that even in managed Kubernetes, the architecture is still the same. All right. The architecture of a self-managed cluster is still the same with a managed cluster, but the responsibility changes. All right. So in a self-managed distribution, you managed everything. You have more control. You have more risks. All right. You are open to more risks and more operational work. But in a managed distribution, you are open to easier upgrades, easier high availability, even fast. It is faster to production. All right, while the provider manages the control plane. So if we are to add everything we have learned in this video together, understand that regarding the Kubernetes architecture, when you run a command, that command goes through the API server. Then the system stores the state of that command in etcd. Then the scheduler decides placement. Then the kubelet on the worker node runs the containers, all right? And the controllers keep watching and fixing. So this is Kubernetes architecture in a very nutshell. So if you keep this mental model, be rest assured that Kubernetes will never feel confusing. So if you stayed with me up till this time, then I so much appreciate you. In the next video, we are going to move into installing Kubernetes locally. So we are going to see tools like Minikube and Kind. All right. Then we are going to take this this series a little bit further. So please, again, do not rush this part. This architecture knowledge is very important. All right. So you need to understand Kubernetes before you can work with Kubernetes. Please, if you have received value from this video, please do well to like this video, share this video with your friends, and also subscribe to my YouTube channel. I'll see you in the next video.